Now I'm going to demonstrate reliability calculation with exponential model or example. Following time to failures of an item are exponentially distributed: 75 hours, 100 hours, 70 hours, 130 and 125 hours. Our task is to calculate the reliability of the item for an operating period of 100 hours. As we have seen and we know, reliability expression for exponentially distributed random variable is given by this expression exp minus lambda t, where t is period of operation and lambda is failure rate. T is given to us, it is 100 hours, and lambda can be easily calculated by using the relationship with mean time between failures. So lambda is inverse of mean time between failure. Mean time between failure for this item can be easily calculated through arithmetic mean of time to failure. That is, mean time between failure becomes 75 plus 100 plus 70 plus 130 plus 125 divided by number of failure, that is 5. It comes to 500 divided by 5. So mean time to failure is 100 hours, and lambda becomes 1 divided by 100.01. So reliability for 100 hours of operation, that's a 100-hour operation, will be exponent minus lambda is 0.01 multiplied by period of operation 100, that is exponent of minus 1. It comes to roughly 0.37. This expression shows that there is a 37% probability that item will survive 100 hours of operation. And this is a very useful information. This has a physical meaning. Let's say if I am running 100 such items for 100 hours, only 37 of them are expected to reach the targets of 100 hours without failure. Or if I am running one item for 100 hours, there is a 37% chance that item will not fail. There is a chance that 63% chance that item will fail. If I know the reliability, we can easily calculate the failure probability Ft. That is, 1 minus RT. So it becomes, failure probability becomes 1 minus 37, that is 0.63. So 63% of the item will fail. That's the information we get out of this calculation. This information can be used for two purposes: planning of maintenance, like how much time shall we run so that we can achieve the fixed reliability targets. In this example, we say by running 100 hours for a given mean time between failure of 100 hours, probability is only 37%. If we want to increase the probability to 50%, what to do? There are two ways of doing it. Either you increase the mean time between failure by proper and suitable design, or reduce the time of operation. We'll look into both the cases now. Now we'll look into a interesting case where reliability target is achieved to be 50%. That is much more than what we calculated, 37%. What to do? There is no chance of improving the design, and still we have to, only thing we can do is to reduce the operating time and achieve the targets. Let us again see the reliability expression for the exponential model. Now we know what is RT, reliability. We also have a fixed lambda, And now we have to calculate the t, that is time of operation. So value of RT given by our condition is 0.5 and lambda is still 0.01 from the calculation we did earlier, and t is the time of operation. To calculate the value of t, let us take log both sides, natural log. So then we have left with the expression minus 0.1 t, and calculate t will be minus log of 0.5 divided by 0.01, which is equivalent to 0.693 divided by 0.01, approximately 69.3 hours. You remember first time when we had 100 hours operating time, we got reliability of 37% only. When you want to increase the reliability to 50%, we need to operate system only at 69.3 hours, roughly 70 hours you can say, and take the system for maintenance. So reliability also defines, as I said in the lectures, maintenance requirements. So we can plan our maintenance, and it's cheaper way of doing things, but it needs more maintenance resources. So if you remember from the first lectures, maintenance and reliability are very closely related to each other. If you reduce the reliability, maintenance cost will increase. If you want to increase the reliability without proper design improvements, then cost of maintenance will increase. This is some sorts of illustration of that concept. Now I will illustrate how can we achieve 50% reliability with 100% operation. Means I have to change the design of the item. Means I have to change the mean time between failure. Now we are looking into a scenario that is design. How design can change so that we can achieve a 50% reliability for 100 hours operation instead of 37% what we calculated for the same item. The only way out is to improve the mean time between failure. Let's write again the expression for exponential model to calculate reliability. Here our reliability value is fixed. We also know the period of operation 100 hours. Our only requirement is to find a new lambda value, that is a failure rate, and that will lead to design of mean time between failure value, characteristic life of the system or item. Let's say again we take a natural log of both sides. We have to learn about that. That will become natural log of 5. Then exponent will vanish. It becomes lambda 100. So lambda becomes equal to log 0.5, as exactly calculations are so simple as in the case of last example, and you get a value of roughly 0.00693, and to calculate mean time between failure will be 1 upon lambda, that becomes 1 upon 0.00693, which comes to roughly 144.3, can be said 145 hours. It's a very interesting observation. If you look carefully, to increase reliability from 37% to 50%, you have to increase the mean time between failure up to almost 45%. And increasing reliability from 37 to 50%, you have to increase, as I said, by 45, and it costs a lot of money. So reliability is not free. But on the other hand, you save a lot of money on maintenance, you increase the safety, reduce many production risks, operational risks. So often as a reliability engineer, you have to weigh all these pros and cons, advantages and disadvantages. These are the three examples. Purpose was to illustrate. It's a very simple example I have taken just to illustrate. Reality it becomes a little complex. Just they are demonstrating. Simple example, I try to demonstrate how reliability can be calculated, how you can change the design, how can you change the operating time so that maintenance can be planned.